You know, we tend to think of science as this ultimate source of objective truth, right? Something built on unshakable facts. But what if that foundation isn't solid at all? We're about to dive into this really fascinating idea called psychologism and ask a pretty wild question. Is science secretly built on feelings?
We've all heard that saying, seeing is believing. It just feels right, doesn't it? If I see something with my own two eyes, well, it must be true. But is that really how knowledge actually works?
Think about it. That feeling of being absolutely 100% certain about something you just saw. It's powerful. But in the super rigorous world of science, is that personal conviction, that gut feeling, is it really enough to justify a fact? That is the big problem we're going to unpack today.
Okay, so let's start with that feeling of certainty. It seems totally natural to think that what we know is based on our personal convictions. What we feel is true.
And this brings us to a huge fork in the road. See, on one side, you have the psychological question, how do I come to believe something? And on the other, you have the logical question, what are the objective reasons that make a statement valid, no matter who believes it? Science, well, it had to choose which path it was going to follow.
And that choice, well, it led science to confront what we can basically call the trap of psychologism. It's this idea that our personal experiences, if we're not careful, can totally lead us down the wrong path. So here it is, psychologism. It's the belief that a direct experience, the act of seeing or hearing something, can be the final justification for a scientific statement. It's the idea that my personal certainty is the bedrock of knowledge. And here's the big problem. The nature of psychologism is completely subjective. It's your feeling of certainty. That's a great topic for psychology, for sure, but it can't be the foundation for science. Why? Well, because your feeling can't be objectively checked by anyone else. It might motivate you, yeah, but it doesn't logically justify the statement for everybody.
All right, let's make this really concrete. I look at this glass, and I have this immediate, powerful conviction that the water is in the glass. I mean, it seems undeniable, right? Under psychologism, that feeling should be enough. Case closed.
But wait a minute. Here's the twist. The second I say the words water and glass, I'm actually using universal concepts. These words mean more than just my single fleeting experience. They have properties and definitions that go way beyond what I'm seeing right now. And all of a sudden, my simple observation isn't so simple anymore. It's actually a mini-theory that goes beyond just my personal feeling.
Okay, so if personal experience isn't enough, what does science use instead? This is what brings us to its objective standard.
Science demands that any statement has to be justifiable, completely separate from anyone's personal feelings. The whole process relies on what's called mutual rational control, which is really just a fancy way of saying we can all check each other's work. This is the logic of knowledge, and it's constantly asking one simple question. By what right do we claim this is true? So how does science actually achieve this? The crucial point, the absolute key that unlocks objectivity, is this concept called intersubjective testability. And what on earth does that mean? It's actually simple. It means a scientific claim is objective, not because one person feels it's true, but because anyone with the right training can go and repeat the test and get the same result. This is what pulls knowledge out of a single person's head and puts it into the shared, public world for everyone to see.
Section 4. Justification through logic. So now we can see how this principle builds a completely different and way more solid structure for knowledge.
So let's compare this to that table on psychologism we saw earlier. Instead of subjective feelings, the foundation here is objective logical relationships between statements. The method isn't a feeling, it's deductive testing, where one statement is used to test another. And objectivity isn't some personal conviction, it's achieved through that really powerful idea of intersubjective testing. And the key point here? Nothing gets a free pass. Every single statement, even the most basic ones, must be testable. So if science isn't built on the solid rock of personal certainty, what in the world is it built on? This brings us to a fantastic and honestly kind of mind-bending metaphor. That's right. The empirical basis of objective science, it's not bedrock, it's a swamp. The entire, amazing structure of science is like a building built on giant poles driven down into a swamp. Let's really unpack what that means. Let's break this down. So the swamp is the messy, shifting, unstable world of our subjective experiences and feelings. You can't build on that directly. So what do? We drive piles into it. These piles are the basic objective statements that we can all test and agree upon. And the building itself?
That's our scientific theory, and it's resting not on the swamp, but on those stable piles we've all agreed to put in place. And this is the most important part of the entire analogy. We stop driving those piles deeper, not because we finally hit some solid, absolute, certain ground. Nope. We stop because we reach a collective agreement that they are firm enough to support the theory for now. It's a pragmatic decision, not some grand discovery of final truth.
And this leads us to our conclusion and the surprisingly powerful nature of what seems like a totally unstable foundation.
So it turns out the great strength of science isn't that it's built on some unshakable foundation of absolute certainty. Actually, its strength comes from admitting that there is no such thing.
So here's the big takeaway. Science flat out rejects personal feelings as justification for anything. Instead, it relies on a logical, objective process that anyone can check for themselves. And this is exactly why it's so powerful. Its truths are held provisionally. They're the best we have for now, and they are strong precisely because they are always open to being challenged, retested, and improved upon. And that leaves us with a final thought to chew on. If science gives up this whole quest for absolute certainty, and instead embraces a system built on provisional, testable agreement, what does that tell us about the true source of its incredible power to explain and shape our world?